Hello, and welcome to the webinar. We are excited to share with you some of the highlights of Cimatron 15 today. Before we get started, I would like to mention a couple of housekeeping items. We invite you to ask questions throughout the presentation by using your Q&A tab on the right, as your phone is muted during the session. We will address the questions received at the end of the presentation. Please note that this webinar is being recorded and will be available soon. The recording will be sent via email along with new sales assets for your use. I would now like to introduce you to our panel of presenters. First, we will have Maoz Barkai covering design, followed by Edith Haran, who will introduce you to the new mill-turn application. And last but not least, Alan Mukhtar will show you some of the new CAM capabilities. And with that, I will turn the floor over to Maoz.
Thank you, Lisa. So today we are speaking about Cimatron 15, the coming version. The timeline, as you can see, is the announcement is happening now, and there is a press release about it. Then at EMO, we are going to show this version, and people can come to our booth and see it in action. Over the next couple of months, we will be releasing some beta versions. Beta 1 has already gone out a while ago. Beta 2 is coming very, very soon. And general availability is planned for end of the year. Our wonderful marketing team has been preparing some collaterals, some videos, and other sales enablement materials. All of these will be made available to you very, very soon. Some of it is already available, and it's part of a much wider campaign that we are launching for Cimatron. So you will get communication about what materials are available and where you can get them pretty soon from the marketing team. So what is Cimatron 15 about? The motivation is, as always, to address the needs of our customers. We have hundreds of features and enhancements in this version, and the target is to reduce delivery time for our customers, improve the tool quality, reduce total cost of ownership, and increase productivity. We will only look at some of the highlights today. We won't even cover all the highlights that you can see in our version highlight datasheet. A few days ago, we had the run-through of the entire version, and it took us 5 hours. So we don't have 5 hours today, so we will only see a few items. So in mold design, we will be seeing enhancements to the cooling design application. In NC, we will talk about the new mill-turn application, more automation tools, and new cutter and cutting technologies. So let's jump right into cooling. And the first item is conformal cooling. So I hope everyone by now are familiar with the technology, but for the benefits of those who may not remember, conformal cooling is 3D printed cooling channels that allow us to go where traditional or conventional cooling cannot go. And so we can get more efficient cooling, and that can help us get a plastic product with less deviation, and also, of course, to reduce the cycle time, which is worth a lot of money. So what have we done in this version? First of all, the user experience has been improved dramatically. The details are very technical. I won't go into them, but please trust me when I tell you it's just fun to work with now, and it's much, much easier to use. We've also added a new tool for automatic creation of the conformal cooling channel path. You will see that in a minute. It's very impressive. It's very fast, and it creates all these intricate passes that would take hours to create manually. It just creates it in seconds, and also that's something that requires great expertise to create manually. So that's actually giving higher accessibility to creation of conformal cooling for people who are less experts in design or in conformal cooling. We are also providing new analysis tools within the conformal cooling tool. So we have an analysis for the printability of the channel. Are there overhanging areas in the channel that will prevent it from being printed properly? And we also have a distance analysis that gives us the distance of the cooling channel from the walls. So you can get the right result on the design and make sure, verify that it's the correct cooling channel that you need. So before I start the demo, please know that this demo is starting in the middle. So I've already designed this part of the conformal cooling channel. It goes along this high rib over here. This takes about 2 or 3 minutes. We don't have time for that today, but I will be uploading a full demo with audio showing all the benefits of the tool with great detail towards the beginning of next week. Okay, so let's start. So as I said, this is the part. You can see the cooling channel. You can see here the great improvements we did on UX. Again, not going into that. We'll go straight into the analysis. And we start with the overhang analysis. So we can see areas where we have overhang, where we have horizontal areas that are too wide to be printed, and they will have collapsing issues or other issues in printing. And fixing it is very easy. We just make the cooling channel a little bit narrower, and that should be enough to cover that. Okay. The next item is checking distances. So immediately we can see that we have issue in the right corner up there. We are too close. The channel is too close to the body, and also we can see that we've skipped this slot here completely. We went right through it. That's wrong, of course. And we can correct that very quickly. So you can see preview is very immediate now. It's much, much faster than it used to be. And I can just drag a few points around and fix these issues. So this is the corner issue that we're fixing now. We already fixed the slot. And then all we have to do is do the analysis again and see if we are in the clear. We can see a little bit of red there near the end of the slot. So again, we just fix that pretty easily. It's all freehand, which is okay for conformal cooling. You don't need exact measurements for that. And we run the test again, and we can see we're all good. Okay, and that's it for the manipulation of the existing cooling channel. What we'll do now is the automatic creation of the conformal cooling channel path. So at first we define the faces. You can see we do it in one click. We define the faces that we want to cool, and then other cooling objects that we want to avoid. We don't want to be close to them. We can select in and out points. In this case, we prepare the places where we want to go in and out. But if you don't do that, the system can provide them for you, and you can prepare holes after that. And that's it. That's the time it takes to create the cooling path for this entire part. You can see how complex it is, and you can imagine how hard it would be to create that manually. So then we select that as an input for the conformal cooling tool, and very quickly we get all the sections in place. They are all aligned correctly for 3D printing, so standing upright. And it's really that simple. It's a few clicks and you have it. Another functionality that we offer now is controlling the direction or the slopes of the ends of the cooling line. In this case, I don't need to change them. They're perfect. And then we can run the same analysis again to make sure that we don't have any overhanging areas that will end in problematic printing. In this case, it will take slightly more time because the path is much longer than the one we used it on before. And that's it. We can look at the results. We see we have a small problem over here. I can fix it the same way I did it before, or play specifically with this area and change the sections. I'm not going to do that right now. And then we can have the distance analysis. I would like to mention that all the analysis here are real time. I did not change the speed of the video in any way. So we see we are all in the clear. There is no way to change anything. I would like to mention that we also have an optimization option here. So if there was a problem, it could move the channel to be closer or further away from the wall as needed. Right, so that was conformal cooling. What I would like to do now is talk about the standalone seat for conformal cooling. So along with the version, we are releasing a new seat. It's really a standalone seat for conformal cooling, and it is directed at non-Cimatron prospects. Those would be mold makers that are not using Cimatron for their mold design, or printing bureaus that are focused or specialized in conformal cooling. And you can use that as a penetration tool to those mold makers, and then maybe you could turn them around to use Cimatron later on. The cost of the standalone package is $6,000 or euros, and we have an upgrade path to Cimatron mold design or to 3D Expert. The next item is the cooling distance map. It's an analysis tool that is like a mini mold cooling analysis, so like you would have in Moldex 3D or MoldFlow. Of course, it's much simpler, not as precise or accurate, but also much faster. And it measures the distances between the active faces, so the faces that touch the plastic, and the cooling lines, cooling channels. It will work both on conformal cooling and on conventional or traditional cooling. And it will give you a quick reading of your cooling efficiency. Again, not as precise as a full FEA analysis, but you can get a quick understanding of where you are. So let's see it in action. We'll start with the same model we had before of the conformal cooling. And then again, we select the cooling channels that we want to examine it on, and then the relevant faces, again, one click, and we have it, and we start the analysis. And once again, this is as fast as it is. That would take at least half an hour to a few hours in an FEA software. So we're waiting 10, 15 seconds, and we have a result. It's really in no time. That gives us a very good indication of where we are. So you can see exactly where you have efficient cooling, where you have less efficient cooling, and you can change your cooling accordingly and spend another 15 minutes and see what you've done and where you are. Let's see the same analysis on a more traditional looking mold. You may be familiar with it. So you can see all cooling channels are selected automatically. If you've used quick split, all active faces are selected automatically, and then all you have to do is run the analysis. If you're familiar with this part, it has all these buffers going into these deep cores, so we can see how they affect the cooling. If these deep cores are efficiently cooled. And here we have the result, and we can see that they definitely make a difference. It looks like all of these deep cores areas are cooled pretty well, and actually we see missing coolings in the outskirts, so on the right and left sides of the mold. Last item on the cooling issue is the cooling labeling. So next to each cooling hole, we would like to put in a label or a number or letter or combination that marks it, so that when we assemble the mold and we need to plug in the hoses, they will be plugged to the right hole. And so we developed a tool that does that in record time. Let me show you what it looks like. So same mold we've seen before. We'll open the cooling labels tool. And here you can, of course, set everything you want about the color and font and size and where it's positioned. But the key thing is the writing. So we can have postfix, prefix, letters, numbers. We can change their order, what comes first, and we can have automatic progression. So automatic progression means we will change either the letter or the number when we click the next hole. So we don't have to write the text over and over again. We'll just change the number or change the letter or change both, whatever we want. And then we can always go and add prefix or suffix and put in our own text, whatever you want. You can put there, but it's all very efficient, very quick, just a few clicks, and you have it for the entire mold. So we'll do the same now for the other side. I'll change the letter to B and the postfix to in, and then I continue. I could have reset the number to 1 and then start from there. In this case, I'm continuing with the numbering from where I stopped in the other side. So a few more clicks. Change now, of course, the postfix to out, and that's it. I have my cooling labeling for the entire mold within less than a minute. So great improvement on time on this tedious task of putting in the text again and again and again and changing it every time. All right, that's it for the CAD and cooling side, and I will move it now to edit to continue with and see.
Hello. Hi. Okay. I'll take control. Okay. So I'm Edith, and I'm going to talk about the new turning application in Cimatron. So in Cimatron version 15, we now support mill turn and turning for faster machining and better surface quality. Here you can see a real test cut that we have done with this new application in Cimatron. So we support, as I said, mill turn and turning machine for faster machining and better surface quality. We use the same GPP2 post engine, and it is possible to combine turning with advanced 5x milling. Currently, we support machines with one turning spindle and one tool changer. We work together with GibbsCAM team, who are part of 3D Systems, and embedded the GibbsCAM engine into Cimatron to gain from both products. GibbsCAM is a mature turning software with over 30 years of experience in late machining in the market. So how this is done, we use a Cimatron environment for the machine definition, the setup, the stock, and the geometry. We use two dialogues from GibbsCAM for the tool definition and for the procedure parameters. And the engine is also used in the background for the tool path calculation. Once the tool path is calculated, it can be viewed in Cimatron using the navigator, the machine simulation, and it can be output using the GPP2 post engine. This way, we benefit from both Cimatron environment for geometry simulation and post, and GibbsCAM engine for robust and mature turning solution. I will go over the workflow in Cimatron. First, the turning cutters should be defined. We use GibbsCAM Dialogue for easy creation of cutters using key dimension. There is a wide variety of predefined common tool shapes and holders, and it is also possible to define custom tools and holders. Once the tool is defined, it is saved in Cimatron's cutter list as part of the Cimatron environment. Our next step is designing of the contour and the geometry. So we have powerful design capabilities for creating the span silhouette of the turning body, as well as all other CAD capabilities for efficient contour creation, for using it in the turning procedure. So now we get to the procedure creation. We support all main turning strategies, include rough strategies for turn, pattern shift, and plunging. Voluturn is also available for high-speed roughing using round inserts. We have an option for contour for finishing operation, and of course, center drilling, grooving, and lay threading are also supported. Turning is supported from all directions: outside diameter, inside diameter, front facing, and back facing. There is a full control over technology. Here you can see GibbsCAM Dialogue. We can change the offset of the cutting, the depth, the side, the orientation, the entry and exit modes, and much more. We use one stock model for the entire process, which is fully updated both for turning and milling procedure altogether. We have a new way to define the stock using a revolved body. Here you can see a bounding cylinder and a revolve using the span silhouette of the body. So it is also possible to define stock in this way. And last step, we want to machine the part, so you can make sure you can use all the tools that are available for Cimatron, such as display, navigation, post, report, and of course machine simulation for the entire process, both milling, drilling, and turning. Now I will show you a demonstration of the entire process in Cimatron. This is the part we want to cut. You can see that we have in the process both turning and milling procedure. The stock is defined as a cylinder, and it is updated both for milling procedure and turning procedures. And if we want to create a new cutter, we can use with predefined cutters. Some cutters we have defined for external and internal cutting, grooving, and threading. And to create a new cutter, we use the GibbsCAM Dialogue, which has a wide variety of inserts and many common sizes to be used for the catalog. There are several holders. Here you can see a tool holder. Previously we saw a boring bar for internal cutting, and once the tool is created, it is saved in Cimatron and can be used later for creating the procedure. And now we'll see the creation of a procedure. So we use the same interface we are used to for creating a procedure with different methods. Here you can see the contour creation, the contour selection. This is a span contour. We can define the start and the end points of the contour and use it in Cimatron. We define the tool the same way. We choose the tool from the cutters list and to be used. And for the procedure parameters, we use the GibbsCAM Dialogue with all the parameters that can be entered and the directions we can define. The tool orientation can also be selected in this way, and the toolpath is calculated. Once the toolpath is calculated, we will now see it in the navigator. We have a new option for showing the section of the part, which enables to see better internal cutting, and we can show the machine simulation for the entire process altogether. You can see a facing procedure, outside diameter roughing. As you can see, all the parts of the machine and the tool with the holder. Here is a lace drilling. Here we see this in a section view, which is, as I said, easier to see for internal cutting. Here is the internal roughing and onto, here we are back to the outside. Here you can see milling together with some lace grooving and some more milling and drilling. So as you can see, the entire process is done in the same environment, in the same way as we do in Cimatron for all NC. And that's it. Now I will pass the presentation to Alon.
Thanks, Idit. Great presentation, and thank you for the product we've been waiting for so long time.
Just a minute. Okay.
Not yet. Okay. So we have seen Milton demo by Idit. Other NC version highlights for version 15 are the plate machining automation and enhancements, enhancements on 5-axis, reduced machining time, and finish enhancements. And we will go through briefly all those items starting now. First is the plate machining. We have in version 15 two seats for licensing, plate machining basic seat and plate machining pro seat. In the Pocket Manager, it was now enhanced and improved for detection of pockets and for automatic detection from main direction, as well as detection of in specific slots and corners. And for those, we have procedures to handle slots and corners. Corner plunging, this is a new procedure allowing the Pocket Manager to detect the corners, and the corner can be vertical or slanted at an angle, and the plunging motion will go parallel to the cylinder, but in 3 axes. This motion will be, of course, gouge-free and collision-free. Here we see in the pocket feature, we see this line, which is the center line of the corner on which the plunging tool will go. Let us see a short movie. Here we see the plunging tool going in forward steps, approaching to the corner, and when finished, switch to the next one, and so on. This is a very efficient milling operation rather than 2D cleanup that we used to have till now. Next one is the slotting. This is a new procedure. Again, Pocket Manager detects the slots for us. There is a parameter we call likelihood, which can give some values to the slots from 0, which is actually not a slot, up to 100%, which is a perfect slot. We can see the center line on which the slotting will operate, and user can also select a different contour if he wishes. Machining then will be done in slotting, ramping, or trochoidal. Here is a ramping example, and here is a trochoidal example. Let us see a movie of that. So this is an open slot, so plunging is very efficient from the outside. And now a narrow slot using ramping and a wider slot using ramping and then trochoidal. So this is very efficient, of course, gouge-free and collision-free. And then other operations will apply to complete the pocket. Moving on to automated drill enhancements, we have automated group naming. So this was previously the group naming by the system. And now, using some preference conditions, system can suggest these naming just by the functions and groups within the system. Sequence numbering is just here to help us manage the sequences, and manually assigned groups. Once when the geometry was changed, we lost all the manually assigned groups. Now it will be kept and no need to redefine those again. Moving on to 5-axis, we have many functions developed here in V15, starting with the automated multi-axis roughing. This function allows us to analyze and suggest the best direction for roughing, for maximum material removal, of course considering the tool and the holder, but also considering the stock, so it is suggested the best orientation for maximum material removal. There are two work modes. The interactive mode, where within the procedure you can click on Analyze and system will suggest a direction, and then you can choose it or choose a different one, or the automatic way, where you can utilize a template or automatic execution, and system will optimize the direction and go ahead and execute the toolpath immediately. So therefore this mode supports templates. Here is an example starting from a full stock, operation 1, procedure 2, procedure 3, procedure 4, for this fixture example. Next is a new procedure for geodesic. This is an advanced finishing. It is more than a procedure. I would call it kind of an application. This creates a toolpath that can be 3-axis, 4-axis, or 5-axis, supporting also undercuts. It has many applications like true 3D step, morph between two curves. It supports a single guide curve or multiple guide curves, and has two work modes, contact mode and center mode. Contact mode supports all type of cutters, and center mode supports ball lollipop cutters, and allows automatic creation of collision-free toolpaths. No need for gouge checking. It is automatically trimmed and fully defined. Let us see some examples of applications related to geodesic. First one is the 3D step. This is a job needed a very high surface quality. So if we zoom in on the toolpath, it's a one single thread toolpath start to end, round corners, no connections, no jump to clearances. A full defined, very, very nice, very high quality toolpath. Next one is the 5-axis undercut milling. In this case, this is a rubber mold. It has undercuts, it has complex shape, and using the geodesic, you can go along this geometry with a ball cutter with 5-axis, in this case 4+1, which is more robust and better surface quality. It will follow the geometry, of course, gouge-free and collision-free. This was not available, not possible till now in a very systematic and smooth method as now. Third example is a 3-axis using a T-slot cutter to handle geometries with undercuts, like this geometric mouse shape. We see the toolpath is morphing between the upper contour and the lower contour, and the T-slot cutter will go 3-axis, but it will cut the undercut following the geometry, of course, collision-free with the shank and the holder. Moving on, another enhancement in 5-axis is the automated multi-axis guided cleanup. The guided cleanup, creates the contours on which the cleanup later will be calculated, but sometimes the holder may collide with the geometry. So now system can analyze the geometry in those cases and suggest automatically best cleanup directions to consider the tool and holder and optimize the cases, and if needed, split the segments even with overlap between the milling areas. And there is an option to snap on existing directions or create new directions. Let us see a short movie about that. These are the cleanup contours as created default by the system. And if we go further down, we can see that the tool and the holder may here collide. And of course, this is not good. Clicking auto direction option, we set some parameters and calculate. And the result is a set of arrows, which is a set of directions for the tool to be positioned. And now the cleanup calculation will be collision-free and automatic. So this is a very robust automation tool. Next is the automated procedure for 5-axis deburring. This toolpath can be 3-axis, 4-axis, or 5-axis. It has the capability of automatic detection of sharp edges, and the toolpath will run on the outer sharp edges of the part with a ball tool or a lollipop tool with automatic collision avoidance and automatic linking leads in, leads out. And the result is very nice, saving a lot of time on programming. So here is an example. The deburring will go on the geometry. It can be, as I said, 3-axis or 4, 5-axis. Here we see a 5-axis deburring of some outer geometry, and here of some inner geometry. Next item is reduce machining time. Here we have enhanced the AFC in the rough procedure. AFC is the automatic feed control. It has been enhanced, including all next roughs as re-rough procedures with a better stock recognition, reducing drastically the load changes and resulting in longer tool life and smoother machining and faster machining. In this example, we see the yellow stock, and the rough operation is a simple one line starting from 0 stock, enhanced to at the middle to the maximal stock, and then go down again to 0 stock. So on the left side, we see the AFC off option. On the right side, we see the AFC on option. The feed is shown in white, and the load is shown in red. So here we see a constant feed as programmed by AFC off. The feed is 1000. And the load goes up and down as we progress along the cut. And this is expected and good. However, at this point, probably the load is very high. It may even break the tool. So what people did normally was generally reduce the feed, and the total efficiency of the motion and total efficiency of the cut was less, and machining time was much longer. With AFC on, even programmed 1000, we can see that the feed is changing up and down, and so the feed may vary, and the load is more flattened respect to the original load where it was with a peak. So the peak was lowered. This means we can increase the nominal feed, longer tool life for sure, and faster machining. So even though this operation or this function was available in Cimatron for many years, it had some problems, and now it is much enhanced and we encourage you to use it and to show it to your customers and let them use it. This is an important machining time reduction and quality in roughing. Next one is the circle segment cutters implementation. We have in 15 completed all the implementation of all kinds of circle segment cutters available. The barrel type, the lens type, the oval type, and the 3 radi new in 15 type. In order to utilize 3 radi cutter shown here on the right picture, we see it has big radius on the walls and on the floor and some connecting radius which is rather small. So system automatically suggests to us what is the best mill slope angles for this tool. So you should utilize this tool with large step over between 0 and 22 and between 68 and 90. So with 4 limits angle in finish procedure now, we enable utilizing the large step over wherever possible. So here we see the large step over for finish procedure for vertical area and horizontal area will be between 0 or 1 to 22 and between 68 and 89 or 90. Small step over for the connecting radius will be between 18 and 33 and 33 and 72, which means some overlap between the 22 and the 18 and 68 and 72. This overlap will make sure all the finish procedures complete the job to the end. Let us now see some use cases utilizing the 3 radi cutter. First use case is the 3-axis for a small mold part. This part is an agitator mold core, diameter 200 by 100 mm. Left side is the standard ball D20. Right side is the D20 3D 3 radi cutter. In this case, we have used the Moldino company, which is a tool company from Mitsubishi Hitachi. You can look at Galea, which is their product line. And this is the tool. It is a 2620 radius. So left side, step over was 0.63 mm. Right side, I used for the same scallop 0.89 and 0.49 in respect for the good area and for the bad area of the tool. Machining time was actually really the same, 1 hour and 41 minutes, 1 hour and 42 minutes. So no change in machining time for small parts. So notes, no time saving. Standard process can be utilized for the 3 radi cutter, and this means cleanup operations to success this finish operation can use previous cutter as ball 20, which is the original diameter of the cutter used. So this process is very robust. And let us now move to use case number 2. Use case number 2 is same 3-axis, but this time relatively large mold part. In this case, this is a car hood, a transfer die shoe of a 2 meter by 1.5 meters. On this geometry, now the difference is very significant. Instead of 132 hours, we were down to 119 hours, which is 13 hours saved. 13 hours of machine time, this is a lot of money on this one job. Please note, calculation time was increased from a half an hour to 5 hours. So calculation time is longer, machining time is faster, and it is a robust process, applying 3-axis TPT template, no problem, works all the way to complete the job. Use case number 3 is utilizing 5 axes on a small component or on any component. Here, same agitator part. Left side is the 3-axis standard ball cutter. Right side is utilizing the taper cutter. Let me run both simulations in parallel, and meanwhile, while I'm talking, you can see the difference in behavior. The simulations are synchronized to the real machining time. So standard ball was about 30 minutes, and a taper cutter 5-axis was 24 minutes. This is already a significant time saving, not dramatic, but interesting. And notes on this use case, this is a local operation, and therefore it has to have some specific programming and not a template process, robust start to end. It has to be more manual in order to complete the job. Now, soon, right picture will complete the milling, and then we'll be left with more milling on the left side. And this is exactly the time being saved on the job. What is important from our side, the message is that we now fully support all 3 radi and all circle segment cutters in V15. Next is the on-machine inspection readback. This is to complete the project of on-machine inspection. We can now read back measurement details coming from the controller after real measurement and inspection on the CNC machine, go back directly to Cimatron, attach the data to the OMI procedure, and the result can be displayed on the screen with a table and with the probes. Green are okay, blue are excessive material, and red are gouging material. Let's see a movie. Starting with the OMI standard operation as we are familiar with. And now, new option, import measurement results. We are now importing data from the controller and then attaching the result to that specific operation, inspection report. And here comes the report as shown and as discussed before. Red is out of tolerance and blue is out of tolerance but excessive material. Moving forward to finish functions, we have now implemented the 3D cutter compensation. We have been waiting for that for a long time. This is used for cases where high accuracy is required. It is allowing the machining of same program over again without the need to recalculate the toolpath, which can take a lot of time, or in cases where the programmer is doing some other job and the shop floor requires highly result now, it needs the shop floor adjustment, and this is not so efficient. So with the new functionality, the shop floor are on their own. Just by modifying the 3D cutter compensation on the controller, the G-code will output the vectors X, Y, and Z of the shape at the control touch point, and therefore the result is good for utilizing several times with just changing the 3D cutter compensation. Next one is the shank and holder control. This is a dialogue which is more than a dialogue. It is an interactive dialogue where the user can control which components are to be checked and which are not, what to check against what, whether do I want to check just the part or against the part and stock, and the method of checking whether is it a mesh or a grid, and what is the accuracy of the grid. So this is rather a very complex, I would say advanced dialogue with many options. Moving the slider, we can see that components above the slider are grayed out because they are not taken into account. And then when I stabilize the slider, we can see that we can control what is checked against the part and what is checked against the part and the stock. And then the method against the mesh or against the grid, and what would be the total value for safety. This one was never shown to the user, and now we have the full control over the parameters, and we have the full information for the user for the result. Also, calculation time, we can calculate the minimal clear length and what to do with gouging motions, remove or keep, and so on. A very advanced dialogue. Next is the utility procedure. This is a new procedure saved in the process manager, where you can save or program messages, codes with sequences, without sequences, and all kind of machine-dependent codes. This is for milling, but mostly for turning, where GibbsCAM procedures used to use utility procedures, so we had the high motivation to develop that, and this is effective also for milling. And as said, this appears in the process manager and kept for later report and management. And this is the dialogue. Last one for the highlights is the support multi and more coolant types. So first we have more types. We can see here a dialogue in the preference where the user can specify which more types would he like to use on top of the flood, mist, through, and air. In this example, high-speed pressure. If this is checked, then also a pressure value can be typed in. Not only that, but also multi-options for coolants are available. So in this case, 2 coolants are available to be output at the same time. With that, I complete the highlights, and we are now to the Q&A session. Maoz, please.
Thank you very much, Alon. So for everyone, if you have questions, please fill them up in the Q&A tab. We already have a couple of questions. So the first one is about cooling. What is the difference between the 2 analysis tools that we saw for distances? That's a very good question, and it can be a little bit confusing, so I'll try to make it clearer. The first analysis we saw inside conformal cooling is checking the distance between the cooling channel and the wall. So for each point on the cooling channel, we see what is the distance for the wall. And that's very important because if the cooling channel is too close to the wall, with erosion, with time, it may breach the wall and we will have leakage. And if it's too far from the wall, then again we have a problem because we don't have very efficient cooling. The second analysis that we saw, which is the cooling distance map, is doing it the other way around. So it looks at the faces, the active faces that touch the plastic, and for each point on those faces, it looks for the closest distance to the cooling channel, to any cooling channel. Okay, so this will give us the efficiency on cooling on all these faces. So the first analysis will not show us anything on the faces, it just checks it for each cooling channel. But it will not show us if it has good coverage of all the faces. The second analysis will look at the faces and show us if we have good cooling coverage and if all points on the faces are close enough to a nearby cooling channel. So I hope that's clear. Alon, I think we have a question here for you.
Yes.
Right. Yeah. Can AFC function only be used in RAF? can it be used for semi-finishing procedure?
Right. So AFC is attached to rough procedure, rough spiral and rough parallel. Volume mill also has AFC of its own. Discussing here the AFC, we actually support all the roughing process. So rough can be in this matter first rough, second rough, or fifth rough, doesn't matter. So we know the stock at any given moment, and we take into account the actual stock at any given moment for the tool and adjust the feed accordingly. So this is a very robust function, and we really recommend and ask you to test it again and utilize it for your customers.
Thank you, Alon. There was something you wanted to address, right, about costs?
Okay. So firstly, from Joao, I see that Joao from Portugal. Hello, my friend. Yes, Erofio will clap on the 3D cutter compensation. Of course, when we did that, we had you and Erofio in our mind. Another issue is regarding the cost of 3-radi cutter inserts. Are they expensive compared to the standard ball tool inserts? So, of course, the 3-radi inserts are more expensive. But even though this should not be the only question to be considered, because assuming the insert for 3-radi cutter will be $10 instead of $1 per insert, this $9 can be very fast turned back if we save one machining hour. So in my example where I show the 19 hours of machine time saving, this is a lot of money, even though you spend some money on the more expensive 3-radi cutters, yet the time saving and the money saving on the machine tool side is much, much more efficient. This reminds me of the same questions came out when utilizing the volume mill. The volume mill solid carbide tools were much more expensive than the standard end mill cutters, yet the volume mill was very nice introduced and penetrated to the market. So same concept.
Thank you, Alon. We have a question from Ralph if you can get the parts to look at the new features. So along with the betas, each beta we release the what's new for that beta, and we are working on tutorials and the full package. So I can't say when we will roll out everything with these parts, but if you need anything specific for a demo for a customer before the release of any specific material like tutorial with parts, please contact us, let us know. We can provide the presentation, the demo, whatever you may need. Okay, are there any other questions? Okay, I can't see any more, and we are close to the end of the hour. So Lisa, if you want to wrap it up, please.
Thank you so much, Mo, Zadit, and Alon for the great information. We are all very much looking forward to Cimatron 15 coming out soon. Again, just a reminder to keep an eye on your email. We'll be sending this recording as well as some sales tools for you to use, so be on the lookout. Thank you all so much for your time today, and enjoy the rest of the day.
Thank you very much, Lisa. Bye-bye.
Thank you. Thank you all.
Thank you. Bye.